Hello everyone, welcome back. In this episode I'm going to show you how we can calculate a bounding box for any polygon shape. Alright, a bounding box. What is a bounding box? A bounding box is a optimization step where we basically put a large rectangle around all the vertices. It's a so that the rectangle is touching the outer rectangle, okay? The important part is that this rectangle um, is always um, perpendicular to the screen. No, it's not rotated, it's always like this. And with this property, then that the rectangle is always standing straight up, um, we can do a very simple collision step or check to check if this bounding box is touching with another bounding box, and if it's touching, then we know, okay, we need to check for collision for rotated shape, because this this collision check for simple rectangles without rotation is really simple to implement and pretty fast. For example, if we had a really complex polygon with a lot of edges, um, then the collision detection between those two polygons without a bounding box will take some time. And we can just put a rectangle um, around that polygon and check for this collision instead first. So we're gonna make sure that there is actually a collision maybe happening. And then we can check the complicated collision step. Alright, for the calculation for a bounding box, we need to get two variables or two values, or let's say two vectors, the top left part and the bottom right part. If we have both of these, we can construct our bounding box. For this, we need the vertices of our polygon. In this case, it's a rectangle. And we do this by searching for the minimum values for the top left, and we are searching for the maximum values for the bottom right. Also, it depends on which coordinate system you're using. In our case, the y value will increase when you go from the top to the bottom. Here on the bottom, the y value is really large, and at the very top, it's zero. The x value in our case on the right, it's larger than on the left side. Sometimes the coordinate system is flipped with the y value. Okay, then the bottom right part, you need to search for the bottom right part for the minimum values, and then for the top left, you need to search for the maximum values. But usually, I think so at least, that the coordinate system should be like in our case. Okay, how we can do that? It's actually pretty simple. We need to iterate through every vertex of a polygon, and that means first we're gonna check, well, at the really first, we have to set x and y to a value, to a really large value. I'm gonna make an example for top left now. Since we need to search for a minimum value, we need to set these two variables first with a really large value. And then we are going through every vertex. The first vertex 0, yeah, the x value, you can see there are other values which are smaller, which are larger, but this first value is definitely smaller than the value we set first initially in our for example in our x component, okay, in the x component of the vector. So we set the x value to the first x value in the vertex, 0. Then we go to the next one, okay? Now we're comparing the value inside our top left on the x with the value on the vertex. And we need to search for the minimum. So that means we need to check if vertex 1 is smaller than the saved value in our top left vector. So it's smaller than this x value. And previously we set this value inside our vector, okay? So this value, the x component of this vector will be, or of this vertex will be larger than this vertex. But we need to search for the minimum, so we're just gonna ignore this one and continue to the next one. We're not gonna search anything, set anything. Okay, then we go to the next vertex. This one also has larger values than our current top left vector. Yeah, then again, we are continuing. We are not doing anything. We're continuing till we found a valid smaller value. Then we go to the vertex 3, and then here the x value is actually smaller than the value we saved earlier. This value, the x value, is smaller than this one, so we override that the x value will have this x value. And then we have the minimum x value required for our bounding box. And this will be this side, okay? Same for the y part. We are going to the first, well, we initially set the y part again with a really, really large number. Then we're gonna set the first value, which is gonna check the first value, the first vertex with the really large number. Of course, the first vertex will have a smaller number, so this one is going to set into the y value, the y component of the vertex 1 as 0 to the y value of top left. Then again, we go to the next one. The vertex 1, the y value is larger than the previous one, so we're going to ignore it. Then we go to the next one. Y2 is also larger, we ignore it. Y3 is also larger, we ignore it. So this one is the smallest. And so we can calculate the top left value. Also, it's the same for bottom right, but flipped, of course. In this case, we are searching for the maximum value, so we have to set x and y for the minimum, a really, really small number. And in this case, we can use values with minus. Okay, like, I don't know, I'm using in JavaScript, I'm using number.max value, I think. And for the max, and for this one, number.min value. And here we're gonna do the exact same thing again, but this time we are searching for the maximum, so we're gonna flip this comparison. Okay, so let's check again. First, we are setting the maximum, the bottom right, x and y value to minimum values. Then we go to the first vertex. This one is of course larger than the value we set previously. So we are gonna set this value into here, all right? The x, we are gonna search for the x value. Then we go to the next vertex. We are comparing this value with this value again. This one is larger. We're searching for a larger value, so we're gonna set this larger value to bottom right, okay? Then we go again to the next vertex. We're gonna compare this vertex again with bottom right. If we have a larger value, which we don't, we're gonna set it. In this case, we're not gonna set it because this value is smaller than the previous one set. And then we go to the next value. This value is again smaller than the value we set in bottom right, so we're just ignoring it, and then we are at the end of our array with the vertices. And that's the algorithm for calculating top left and bottom right. And with these two variables, we have everything we need to construct our bounding box, also to do the check for intersection. All right, that's it for this presentation. I hope you got a glimpse how to calculate a bounding box. We're going to do it in the next episode then. All right, then have a nice day and see you there.